Hi students, in this video we will discuss about binary search. So first of all, what is searching? Checking whether the given element is present or not. So in the last video we have seen about linear search. So the drawback with linear search is it will search sequentially or continuously one after the other. Suppose if the size of the list is very large, it takes more time for searching. Suppose let us assume that if there are 1000 elements, in order to say that the element is not available, so in linear search it has to take 1000 iterations, then it displays the message search element not found. So even if the element is available, if it is available more than 500 times, so more than 500 the position in that list, it will take more time for searching. So to rectify that drawback, binary search has been introduced. In binary search, the condition here is before searching, the element should be, all the elements must be placed in sorted order. All the elements should be placed in sorted order. So the technique of binary search is similar to searching for a page number in a textbook. Let us assume that we have a textbook with 1000 pages. Now if you want to open a page 700, so what is our method? What we will do? So 700, it is more than half. We will try to take some page. Let us assume that the page number 500 is opened. Then what we will do? Then we will compare the search page 700 is equal to 500 or not. No. Then what we will think? So 700 is greater than 500. So we will search in the right part. So in the left side, the element, that page number will not be available. We will search only in the right part. So similarly in every iteration, so here that 700, if page is available, it will be available right side. Left side there is no possibility. In this way what happens is, in every iteration the list will be divided into two parts. That is why it is called as binary search. That is, if it is equal, it will stop. If it is greater, we will search right side. If it is less, we will search left side. Similarly, the same technique is followed here in binary search. While searching the elements also, we will follow the same technique. That is, here it will be compared with the middle element. If it is equal to the middle element, we will stop. If it is not equal, then we will check whether it is greater or smaller. If greater, we will search in right half. If smaller, we will search in left half. Now let us see one simple example. Now let us assume that we have the elements like 10, 20, 30, 40, 50. I have taken in order. You can take in any elements, but it should be in increasing order. Okay. Now here the procedure here is, initially we will take two variables called, so initially we will take two variables, left equal to 0 and right equal to n minus 1. So initially we will have two variables called L and R. L points to the leftmost element, R points to the rightmost element. L points to the index of first element, R points to the index of last element. Then next what we do here is, while left less than or equal to right, while left less than or equal to right. So here, so this process we will continue until left value is less than or equal to right. Once left value is greater than right, then we can say that search element not found. Okay. Now let us assume that the key element here is, the element what we want to search here is, let us consider that element as 80. I want to check whether this 80 is available in this list or not. I want to check. So what we need to do here, so first we'll compare, check, that is mid equal to left plus right by 2. What is mid value now? Left value is 0, right value is 9. 0 plus 9, 9. 9 by 2, that is 4. Now mid will point to the index 4. So mid is pointing to index 4. Then what we do here, Then compare if key element is equal to A of mid. If key element is equal to A of mid. So what is the key element? 80. 80 equal to 50? No. If it is equal, so what we do here is, so we'll take one variable called either flag or found. So found equals to 1. Initially found value is 0. Then break. Found equal to 1. Then break. That is come out of the loop. Then if it is not equal, if key element is not equal to A of mid, then what we need to do? Else if key element greater than A of mid. If it is greater than A of mid, then we need to search in the right half. Now observe here, what is the key element? 80. A of mid is 50. 80 equal to 50, false. Then we need to check whether it is greater than mid or less than mid. Key is 80, A of mid is 50. 80 greater than 50? Yes, it is greater than 50. So greater than 50 means if the element is available, then it will be, there is no guarantee that it is available or not. If the element is available, it will be available in the right side only. There is no possibility of left side. So what we do here is in the next iteration, we will search for the element only in the, we will search for this element only in the right half. So in the next iteration we have only these elements, that is 60, 70, 80, 90, 100. Now we have only these elements and their index numbers are also same, like 5, 6, 7, 8, 9, and R is pointing to the last element. Now if you observe here carefully, if key element is greater than A of mid, then this will be our list. So what we need to do, L should point to this element. How this L will point to this element? So this is immediate of mid. So what we need to do here is we need to assign, so L equal to mid plus 1. L equal to mid plus 1. Then with this what happens? This L will point to this location. Okay, so if the key element is greater than A of mid, L equal to mid plus 1, that is L will point to this location. Suppose if the key element is less than A of mid, L will be in the right position, R should point here. Then what we need to write here? So R equal to, right should point here, mid minus 1. So if the key element is greater than A of mid, it is equal to, left equal to mid plus 1, then right else, so else right equal to mid minus 1. If it is less than, then right equal to mid minus 1 we need to assign. Now so as it is greater, L equal to mid plus 1. Now L value is 5. Now here again it comes to the loop. Now L value is 5, R value is 9. 5 less than or equal to 9? S enters. 5 plus 9, 14. 14 by 2, 7. Now mid will point to this location, that is 7. So now key element is, what is the key element? 80. A of mid is 80. 80 equal to 80, S. So found value become 1, break. Through break it comes out of the loop. Okay, so even if it is not equal to 80, then what we need to check whether it is greater than 80 or less than 80. If it is greater than 80, we'll check in the right part. If it is less than 80, we'll search in the left part. This is binary search. Now let us see the execution part. Here this is our program. Now I will trace and show you the program. Let me trace and show you the code. Now I enter the array size 10. So accept the first element 10, second element 20, third element 30, fourth element 40, fifth element 50, sixth element 60, seventh element 70, eighth element 80, then 90, then the last element 100. Now enter the key element. Which element you want to search? I want to search for 80. So here now you can see here we have some list of elements. So this is the array list. Okay, right up to here we will take. Then left value, right value and mid value. So enters into this block. Now left equal to 0, right equal to n minus 1. So 0 less than or equal to 9 enters, mid equal to 4. Then key element is, what is key? Then 80, a of mid. What is a of mid? 50. So key equal to, that is 80 equal to 50 false, 80 greater than 50 s, l equal to mid plus 1. Now l value becomes 5. So 5 less than or equal to 9 s. 5 plus 9 14, 14 by 2 7. Now mid value is 7. Now if you observe here, key element is 80, a of mid is also 80. Then enters into this block, found value equal to 1, break. Then found equal to 1, display search element found. So remember, in binary search, every iteration the list will be divided into two parts. If it is equal to mid, it will stop. If it is greater, it will search in the right half, left part will be ignored. If it is less than, searched will be in the left half, right part will be ignored. In every iteration, the list will be divided into two parts. Thank you for watching. See you in next video.